Hi everyone, welcome to the Earth Science Regents Review podcast series created by Hammock's Middle School Earth Science Department. Today we're going to be talking about wind. Now the big thing about wind is understanding how winds are actually going to form. Well, winds first off are going to be the horizontal movement of air across the surface. And they're going to be caused by convection, which is ultimately going to be the uneven heating of the surface. Warm air is going to rise, cold air is going to sink. That's going to cause a convection cell. Once convection occurs within the atmosphere, you're going to get yourself a wind. Now, winds are always going to blow from high pressure to low pressure, and the big thing to remember about this, and I've also mentioned this in my podcast on pressure, is that winds around high pressure go clockwise and outward, winds go around the low pressure center counterclockwise and inward. So again, here's your example of what a convection cell is going to be. Low density air rises, that's going to be hot. High density air sinks, that's going to be a little bit cooler. Well, how do we actually measure wind? Well, there's actually two pieces of equipment that we're going to use. We're going to use an anemometer, that's going to measure wind speed, and a wind vane is going to give you direction. Now, the big thing about winds in terms of direction, winds are named from the direction in which they come from. So if you watch a forecast and you hear that the winds are a southeast wind, that means the winds are coming from the southeast. If it's a northwest wind, the winds are coming from the northwest, and so on. So there's an anemometer, the wind gets picked up in a cup, and that little contraption spins around. Faster it spins around, faster the wind speed. And also there is a wind vane that's going to tell you wind direction. So with wind speed, the big thing about this is when you look at a weather map, look at the isobars. Isobars are going to be lines that measure equal air pressure. Now, there's going to be a little pattern that you're going to be looking for. When those lines are close together, it means you have very fast winds. When they're really far apart, it means you have very slow winds. This is what we call the pressure gradient. And in order to identify whether or not you have a fast wind or a slow wind, you want to look for the biggest pressure change. That's going to be the key here, is looking for the biggest pressure change. So here's a weather map for March 10th of 2010. And you'll notice in the highlighted region, you'll see how your isobars are very close together. That's just one small example on this map that shows you where you have a very high pressure gradient and you have some very strong winds. So in this example, you'll see on the left-hand side, that's going to be a specific distance. And you'll notice, let's just say that distance is about a mile worth of distance. And the change there, you're looking at a 36 millibar difference. Let's just say that this is about a mile difference. On the right-hand side, you're only looking at about an 8 millibar difference. Now, not only are the lines closer on the left, you also have a stronger gradient. You have a bigger gradient. On the right-hand side, you have lines are much, much further apart, and you have a much smaller pressure gradient. So that's an easy way to remember and how to calculate wind speed. So there are two different types of local winds that occur on the planet, and a lot of this is going to occur close to the shoreline. The first one's what we call a sea breeze. These types of winds actually occur during the daytime, where you are going to have a very big difference in specific heat of land and water. We know the beaches are going to heat up very quickly. We know the water is going to heat up very slowly. So you tend to have the higher pressure over the water because the water is cool. You're going to have the lower pressure over the land because it's a little bit hotter. So you're going to get a convection cell that's going to come off of the water towards the land. That is what we call a sea breeze. Now remember, winds are named from the direction in which they come from. If it's called a sea breeze, the wind is coming from the sea or the ocean. So here's a quick example in terms of what a sea breeze might look like. The warm land is going to have low pressure, which is going to rise. The cool water is going to be much cooler. Higher pressure is going to sink. So you get a convection cell off of the water to the land. There's your sea breeze. Well, at nighttime, you get the exact opposite. You get what's called a land breeze. This is going to occur during the nighttime, and again, you're going to get differences in specific heat. Water has a high specific heat, so it heats slowly through the day. Land has a low specific heat, it heats very quickly through the day. Well, at nighttime, it's exact opposite. Water cools off very slowly, so it's quite warm, and the land cools off very quickly, so it's quite cool. So now the warm water, you're going to have the low pressure where the air is going to rise over the water, and the land is much cooler, so you're going to have higher pressure, that air is going to sink. Now what's going to happen is, winds are named from the direction which they come from. The wind comes from the land to the water, and that's what we call a land breeze, so everything is exactly reversed. So, not only do we have local winds, but we also have global winds as well. And the one thing you have to realize is because the Earth rotates on its axis, we get a phenomenon called the Coriolis effect. So in the northern hemisphere, all your winds curve to the right. In the southern hemisphere, all your winds curve to the left. And it's all due to the rotation of the Earth. That curvature is called the Coriolis effect. Now you'll see here that your winds, again, when you're looking at the equator, looking towards the North Pole, that's a deflection to your right. When you're at the equator looking to the South Pole, that's a deflection to your left. And you can see here that your winds seem to be traveling in a bunch of different directions. Well, it's very important to understand that winds blow from high pressure to low pressure. So where you have high pressure, that's where winds are going to start. Where you have low pressure, that's where they're going to be blowing towards. So you'll see, especially on the left-hand side of this diagram, you'll see that your winds go from the North Pole, which is 90 north, they blow to 60 north. They blow from 30 north up to 60 north. They blow from 30 north down to the equator. They also blow from 30 south to the equator, from 30 south to 60 south, and then from 90 south to 60 south. So you see that there's a variety of directions in which they're going to be blowing towards, but again, they're always going to follow the rules of the Coriolis effect. Curvature to the right in the northern hemisphere, curvature to the left in the southern hemisphere. Now the one location that's important to us here in the United States is between 30 to 60 north. That's a wind belt called the westerlies, and that's essentially where we get what's called the jet stream. And the jet stream is going to be a wind belt that basically takes all of our weather from west coast to east coast. And it's going to be very, very important in a lot of our different storm systems that actually travel up through the northeast part of the country here. Now the last part that I just want to focus on are what we call monsoons. Now monsoons are gigantic land breezes and sea breezes, and they really have a major influence on the climatic conditions of Southeast Asia and India. Now there are other locations on the planet that do get monsoons, but these are going to be the most prominent. In the wintertime, the land is very cold, and the water is still a little bit warmer. So winds are going to blow from where it's cold to where it's warm, high pressure to low pressure. So it's going to be very dry and very cold. You're going to really have a continental polar air mass in that case. It's the summer monsoon that gets all the notoriety here because you tend to get the cooler water and you tend to get the hotter land. So the wind is going to go from the water to the land, from high pressure to low pressure, but since it's coming off the water, it's going to be loaded with moisture. And once that air mass hits the land, locked up with all that moisture, it's going to drop a tremendous amount of precipitation. So you always hear these summer monsoons tend to drop tens of inches of rain per day in areas of Southeast Asia and India. But the monsoons are not necessarily storms, they're all caused by major winds. They're almost like a gigantic land breeze and sea breeze based upon the different seasons. So with that being said, that's pretty much it with our winds. I do have another podcast on the global wind chart that is in your reference table, so make sure you check that out as well. That's it for now. Bye.